afternoon, everyone. This is Jamie from Rexel. We're just going to hold on for a minute or two, just to give a few more people a chance to attend, and then we'll get underway. Just bear with me a couple of moments. Okay, brilliant. I think we're ready to start now. So yeah, good afternoon, everyone. Thank you for joining today's webinar with Harry Russell from Eaton on the principles of good emergency lighting. This is a recorded webinar and will be available to watch on demand from next week via our website, so you can re-watch it if you want to refresh your mind. If you have any questions throughout the webinar, enter them into the Q&A box and we'll go through the questions at the end and try and answer as many as we can. This is a CPD accredited webinar. CPD certificates will be sent directly from CPD, which can take up to 4 or 5 weeks, so bear that in mind. Now just handing over to Harry from Eaton, who will take us away.
Yes, good afternoon, everyone. Thank you for that, Jamie. We'll have a few slides of an introduction to Eaton and myself, but it's literally only a couple of slides, and then we'll run through the bulk of the webinar, which is the principles of good emergency lighting. And it should give you a good flavour of all things emergency lighting and applications. So firstly, a little bit of an introduction to Eaton. We're a global business, around 20 billion in sales with a 2 billion net income. We primarily have sectors in electrical, aerospace, hydraulics and vehicles, a vast array of different sectors we cover, such as house and industrial environments, UPS, quality backup, power distribution, anything from HV to LV, and golf grips of all things. So quite a large range of products over multiple sectors. Again, you know, some of the truck and aerospace areas. So we solve power management challenges in multiple sectors, and some can be shown there. Now, today we'll be talking about the principles of good emergency lighting, and a little bit of a background about myself. I'm the technical support manager for emergency lighting within the UK. I started in 2010 as an apprentice lighting design engineer, spent around 7 years in that department. So really my bread and butter was emergency lighting and general lighting application design. Around 7 years, and then I was invited to move out onto the road and support the likes of our sales engineers. So I started off as an apprentice. I worked through until I got my degree in building services engineering, which I believe allows me to have a little bit of a holistic approach, a holistic view of emergency lighting and other services within a building. My sort of key responsibilities are system selection, application guidance, and total cost of ownership. So enough about me. We'll move into the main part of it. So emergency lighting. So the legislation for emergency lighting generally falls under the Regulatory Reform Order, Fire Safety Act 2005 in England and Wales. Now that act is mirrored in Scotland and Northern Ireland with very similar names. So the Fire Scotland Act 2005 and the Fire and Rescue Services Order. Now generally the wording is very similar. There is some slight changes to the wording and some of the responsibilities, but in principle, the ethos of the regulation is very similar, which is the application of keeping people safe within the building, which emergency lighting falls under. Now, it applies to the majority of premises with some exemptions around construction sites, underground parts of mines, transport vehicles or military sites. All the dwellings are exempt. HMOs or houses of multiple occupation and common areas of flats and student accommodation are in scope, and it places an emphasis on the responsible person of the building to develop a risk assessment and to ensure that people within that building are safe. To carry out those risk assessments, and again, duty holder in Scotland and appropriate person in Northern Ireland. They're normally the employer or the building owner, but in some circumstances there can be more than one person who has an influence over the fire safety of a premises. That's particularly relevant in sort of lend-lease applications where you may have more than one responsible person. And again, the need to carry out a fire risk assessment, produce policy, develop procedures, and produce staff training and fire drills. Provide safe means of escape, escape signage and sufficient emergency lighting, and they can use competent engineers to provide that service if required. Now, competent person, so if not trained themselves, the responsible person for that building must appoint or contract a competent person on their behalf to carry out a risk assessment. Now, just in terms of some of the breaches, and just to give you an idea of really what happens when it all goes wrong in the UK. So these are fines and prison sentences for breaches of the regulatory reform order. Now, these specific examples do mention the lack of emergency lighting. There is many more examples on Google which may or may not include emergency lighting breaches. But to give you an idea, the fines are now unlimited. There previously was a limit. So in sort of 2010, there was a £400,000 fine for a prominent fashion retailer, and you will be able to find them on Google. 2013, student accommodation was fined £150,000. Now, prison sentences is quite unusual because there's been a change in the law fairly recently on the Corporate Manslaughter Act. Previously, there was a limitation, I believe, of around 4 years, but that's now been up to 12 years. And they tend to get reserved for the most arduous breaches of the regulatory reform order. Generally, landlords and hoteliers tend to receive prison sentences. But again, sort of some examples there, and again, you can find more on a search engine that reference emergency lighting. Okay, so let's move on to the main approved code of practice for emergency lighting within the UK. That's BS 5266-1. There is others, and I'll try and reference the others as we move through the CPD. But like I said, this is the main approved code of practice for emergency lighting within the UK. Now, the new standard, the 2016 version, does place an emphasis on the risk assessment and the responsible person. So it is worth, that's why we ran through the sort of the responsible person towards the start of the CPD, places an emphasis on them and the risk assessments of the building, and where enhanced emergency lighting levels are required. So 5266, and we will move through this, does call for minimum levels, but it does state that, you know, risk assessment should be used for enhanced areas where appropriate. Now, the principles of a risk assessment is balancing the risks with suitable provisions. So things that should be considered, though not an exhaustive list, are the types of activities within the building, the structure of the building, the layout, the occupants, the types of occupants, and the quality of testing staff. And suitable provisions are things like emergency lighting, enhanced light, emergency lighting, exit signs, passive protection, etc. So it's balancing the perceived risks of the building with the suitable provisions, which can include enhanced emergency lighting. Okay, so types of emergency lighting. There's 3 columns that you should be able to see in front of you. The one that most people are most familiar with is the column on the left, which is emergency escape lighting. And that is emergency lighting which is provided under a power failure to allow people to immediately evacuate the premises. Now, we do see in some circumstances, it may not actually be appropriate or required to evacuate personnel without out of the building. For example, you might have a power failure in the middle of the day. There might be plenty of natural daylight, for example, and a power failure may not, you know, there may not be any associated risk. So this new requirement has come in under emergency safety lighting, which is the central column. So that says, depending on the risk and the system, the occupants may be allowed to stay in the premises in the event of a failure of the supply. Now, there is additional requirements around that, which are shown on screen. I'll not read those out to you, but essentially it allows people to stay within the building and perform light duties rather than maybe the full duties. Now, the last column on the right-hand side, that's standby lighting. I don't touch too much on it on the CPD because it tends to cover things like essential and non-essential supplies and multiple levels of redundancy. Think of something like a hospital where you provide lighting where normal activities can continue, but indeed maybe additional precautions are needed to meet escape and safety requirements. So I don't tend to cover that too much. So if you are familiar with the previous version of BS 5266-1, which was in 2011, some of the main revisions are endorsing a change to a single exit sign format, which we'll pick up later. The scope now includes safety lighting, which we've just talked around. There used to be a deviation within the UK that allowed a very low light level of 0.2 lux upon escape routes if you could prove that that escape route was permanently unobstructed. That has now been removed, and minimum levels should be 1 lux at all times, but we'll touch upon that in a moment. There's some recommendations for specific risk applications, a clause around external emergency lighting, and some clauses around existing installations which may not comply with the current standards and how to potentially rectify that. So 5266 provides a diagram to assist designers, and I like to start off on this page as it just gives a nice overview which we'll build upon. So this diagram shows areas which require emergency lighting. Now, blue areas are open areas, also known as anti-panic areas, where a 0.5 lux emergency lighting level is required, which is any spaces over 60 meters squared, any toilets over 8 meters squared, or indeed any areas which are identified as either having an escape route passing through them, or indeed in the risk assessment. Now, any red areas on that diagram is the escape route corridor that requires 1 lux minimum, and any areas in green potentially may not require emergency lighting. So spaces under 60 meters squared which are not a toilet and generally there's no sort of perceptible risk within those areas, so they're not identified within the risk assessment. So based on that diagram, we'll now try and build that knowledge up around emergency illumination and application requirements. So as I mentioned earlier, open area or anti-panic, the lighting is provided to avoid panic and provide illumination, allowing people to reach an escape route. Now that's generally identified as a space above 60 meters squared, or indeed if an escape route passes through it, and any toilets above 8 meters squared, or indeed any toilet which is for ambulant use, or indeed identified by a risk assessment. Now the requirements are 0.5 lux, with a 0.5 meter outer boundary excluded, and a diversity ratio of 40:1, and that's a maximum minimum ratio. So if you hit 0.5 lux, let's say, as a minimum, your maximum illumination in that room should be 20 lux, and that allows people to escape without the response of the eye essentially responding to a high peak and a very low minimum. Each compartment requires 2 sources of illumination, and a compartment is any open area or escape route requiring emergency lighting. And there is a note that glazing panels in doors that allow suitable illumination from an adjacent location may be acceptable to form part of that 2 sources of illumination. So I like to touch upon spacing tables. I think spacing tables are great because they provide a very quick and easy method to identify how many emergency luminaires you need within a space, and majority of products have spacing tables available. So this is one of our products, a guide-led SL, but essentially you select the correct optic. So in this particular instance, it's a symmetric optic, which means it's symmetrical in both directions, and you select the illuminance that you require. So for open areas, you require 0.5 lux. Then you read the mounting height. So in this particular example, I believe I've chosen 3 meters as a mounting height. And then you read the distance to the wall, which is L1, and L3. Now they're in brackets because of that 0.5 lux, and you plot that on a drawing, 5.2 meters from the wall to the first fitting, and then you read the distance between the luminaires, which is 12 meters and just shy of 12 meters, 11.9, and you can plot that on a drawing. Now you can plot that up for any sort of square area. You're able to immediately calculate the amount of luminaires in the room and plot that on the drawing, and then quantify how many emergency luminaires you require for that 0.5 lux in that open area. So I do believe they're quite powerful tools, and you can repeat the spacing until the area is complete. Just a very small note on that. So that has symmetrical distribution. So the figures are very similar between the two directions of the luminaire. So if you have a luminaire in sort of a 0 degrees or 90 degrees, it's very similar. Just be aware if you have sort of asymmetric distributions, you might have a linear product. They may be different in different directions. So we'll have a look at open areas. Escape route definition. So an escape route is a route designated for escape to a place of safety in the event of emergency. It's generally identified by the fire escape strategy, but generally all circulation spaces are escape routes. Now the requirements are 1 lux down the center line and 0.5 lux elsewhere over that escape route, with a 0.5 outer boundary excluded. And again, diversity ratio applies, and again, the two sources of illumination requirement applies. And again, very similar story in terms of escape route spacing tables. You select a asymmetric product, which provides 1 lux down an escape route, and you do the same again. Select the mounting height, read the distance to the wall, so 7.3 from the wall to the first fitting, and then read the distance between the luminaires, 16.1. Repeat the spacing until the corridor is complete, and 2 times the L1 distance, which is the distance from the luminaire to the wall in the other direction, is the maximum width of the escape route. So these are very useful spacing tables for calculating open and escape route spacing and allowing you to plot emergency luminaires. Okay, so they're the requirements for open areas and escape routes. Now, 5266 calls for luminaires specifically cited at locations, and the locations will be on the following slides. For the following examples, near is defined as within 2 meters horizontally, and I will explain that on the following slides. And at means that the emergency luminaire would illuminate in both directions. I'll explain that as I run through the slide. So, for example, a luminaire is required near to stairs, so within 2 meters horizontally of that stair, an emergency luminaire must be placed. Now, this is particularly relevant in the age of LED luminaires, where you may have, I don't know, 15, 16, 17 meters between luminaires. In that particular example there, where there's only 4 steps, you could easily place luminaires 9 meters either side of that stair core. Now, that's not appropriate, and there does need to be a luminaire within 2 meters of that stair. So each tread should receive direct light, and again, illumination requirements should be met. So 1 lux as an escape route, 0.5 lux for open areas. Same for near changes of level. An emergency luminaire must be placed near, again, within 2 meters horizontally. Near to each exit door, intended to be used as an emergency, so again, within 2 meters. To illuminate any safety signage, and we will touch upon safety signage towards the back end of this CPD. At each change of direction, so at means that the emergency luminaire illuminates in both directions. So if it is on a corner as shown, it does need to illuminate in both directions, and at each intersection. Near to first aid posts, so again 2 meters horizontally, but 5 lux vertical illuminance is required on that first aid post. So that allows people to be able to identify that first aid post and, for example, identify the contents of that first aid post in a power loss situation, which is why there's an enhanced level of 5 lux. Now, there is a requirement there. You see what's known as a European norm, so EM 1838, which is a European norm for emergency lighting, and it is adopted by the UK as a BSEN. So that requirement, even though it is under EN 1838, still applies. Near to firefighting equipment and call points, again, very similar situation. If that piece of firefighting equipment needs to be used in an emergency in a power loss event, the 5 looks allows people to read the label, identify what type of fire extinguisher it is, water or foam, for example, and to use it on the appropriate fire and operate it correctly. And very similar for call points, allows people to identify. So that enhanced requirement comes in of 5 looks. And again, you sort of mentioned around 2 luminaires per compartment. We've previously discussed it. So sighting of luminaires, and I think it's worth talking around this. So in the 2011 version of the regs, it used to be acceptable to just place an emergency luminaire near to each final exit. So typically you would allow an emergency bulkhead, for example, over the final exit door into your external space to illuminate in an emergency. The requirement now is that you continue the escape route outside of the building until a sufficient place of safety. Now, in lieu of other information, I typically see that as the fire muster points, for example, outside the building. So emergency lighting should now continue external to the building. So as said, a risk assessment should define that place of safety, and existing installations might have used external street lighting to illuminate external exits. And really, this should be reassessed to confirm that the street lightings will be illuminated at all times the premises in use. Otherwise, you need to bring that requirement back up into scope and allow sufficient emergency lighting externally. And again, that is existing installations only. That cannot be used on new installations. So they're the specific positions where emergency luminaires need to be placed. There is some specific locations which require typically enhanced levels of emergency lighting. Now these are detailed under Annex E of 5266-1. Some defined locations may be identified and need an enhanced emergency lighting. They're not to be confused with high risk areas, which are generally identified by the end client using a risk assessment, or should I say the responsible person for that building. And a high risk requirement may be, for example, a laboratory, which requires 10% of the general lighting. So these are specific locations and not high risk locations. Okay, so we'll run through some of these. So a disabled refuge area requires 5 looks both horizontally on the floor and at any communication devices and signs on the wall. Fire alarm call points we've touched upon, 5 looks. If there is any panic bars or security devices on any internal doors or indeed final exit doors, 5 looks should be provided on those devices, such as a break glass or the push bar. Plant rooms, switch rooms and winding facilities for lift requires 15 looks in the plane of the visual task. Now the plane of the visual task is really a catch-all for saying anywhere where maintenance personnel may be required to perform a task under a power loss event. So they may have to wind a lift, for example, using a manual winding facility. So 15 looks would be required in that location. 5 looks we've mentioned on the firefighting equipment and call point. The kitchens horizontally on the working plane and on any switches and cutouts such as gas isolation or electrical isolation points. And again, we've mentioned the fire equipment. Reception area, 15 looks on any fire alarm panels and also any repeater panels, and generally also any maps located, such as zone maps located adjacent to the panels. And that allows the fire authority to be able to read the panel and any zone maps and identify the area of fire. And then finally, 15 looks on the reception desk on the telephone/switchboard. Treatment rooms require 50 looks, should I say, horizontally on the working plane. And first aid rooms require 15 looks horizontally on the working plane, with the general perception that first aid rooms is not as unlikely to be as sort of obtrusive procedures going on, shall I say. And unfortunately, I don't have a image for this, but swimming pools, surrounds, swimming areas and diving areas require 5 lugs horizontally on the floor and any treads, such as steps up to a diving area, for example. Okay, we'll have a look at exit signs now and run through the requirements for exit signs and the types of exit signs available on the market. I didn't know if Jamie said at the start of the presentation, but if you do have any questions, please feel free to put them on the chat, and I believe there is we'll answer and we'll try and pick them up at the end of the CPD. So exit signs, position and style. So moving, we'll focus on the table on the right hand side, and we'll work actually from the bottom up in terms of the style of exit signs. So in 1974, we had a sign with just the word exit on, white background, green text. They actually should now be removed from a building. They're actually deemed not acceptable under the Health and Safety at Work Act and the Signs Directive. A pictogram format should be used. So in 1990, we moved to a pictogram format, but with the word exit on the sign. We then harmonized with the European community in 96, and we took the running person outside of the door. Otherwise, we still had an arrow on a door. And then in 2017, we harmonized with the international community, which is an ISO 7010 sign, which is a pictogram format, running person in the door, and a directional arrow. So they should be used in all new build cases. What I will say, it's quite difficult to get EU signs now. Some manufacturers do still stock them. We stock a few for a few products. And they should really be used if you have an existing building. Well, there's 2 options. You either continue with the same sign. So if you have a building and you're doing an extension with Euro signs, you continue those Euro signs, or you go back and replace all of the signs for the international format, that ISO 7010 format. To make things a little bit more complicated, the previous format, the Euro format, 1996, the general strategy was to use arrow down above a door to essentially lead people through a door. That has now changed to arrow up as to lead people through doors, or continue on from here. So it is now an ISO 7010 format above doors, and it should be arrow up to lead people through doors. Now, the positional requirements, which is the table on the left, comes from 5266-8, which is a sort of a supplementary reg. It's also known as 50172, I believe. But BS 5266 is a sort of British interpretation of that. Positional requirements generally as per the escape strategy, the fire escape strategy, but there is some wording around that. So where direct sight of an exit is not possible, a series of signs shall be provided to guide occupants to the exit, and the exit sign should be visible at all points along the escape route. They shall be uniform in colour and format. Luminance, which is a measure of brightness, should be comply with the M1838, and maintained exit signs should be used where occupants are unfamiliar with the building. Now, maintain means essentially permanently illuminated. So if it has an internal lamp, it should be on at all times in a public space where occupants are unfamiliar with the building. I must say that I do see most exit signs now being driven as maintained, because you can almost always make an argument that people that are unfamiliar with the building may be using that building. For example, a school would have parent days where parents would be visiting school, and they would be unfamiliar with the building, and therefore the exit sign should be permanently maintained, permanently on. Yeah, just to highlight that sort of exit sign, the ISO 701 format should be used, and I think I touched upon the arrow up anyway. So internally illuminated signs. So there's 2 types of signs: internally illuminated, where a sign has its own dedicated lamp, typically LED nowadays, to illuminate the sign, or indeed you can externally illuminate a sign, and we'll touch upon both. Now, the requirements for an internally illuminated sign are EN 1838 and EN 60598-2-22. Now, I do mention 60598-2-22, but what I will say is it's not something particularly that that you have to worry about particularly. So it is a product standard that manufacturers should follow to ensure their products are compliant. So for example, our exit signs need to meet 10 to 1 maximum to minimum luminance ratio, a minimum overall brightness, and a contrast ratio between colors. And really, we do need to meet that standard to place those luminaires on the market. So it's not really one that you need to worry about, particularly those individual requirements, as long as the product is compliant with that 60598-2-22. Okay, otherwise externally illuminated signs. If a sign is not illuminated, is illuminated by an external source, the vertical illuminance should be not less than 100 lux under normal lighting conditions and should provide not less than 5 lux on any part of the sign under a mains failure conditions. And that vertical illuminance should be provided by a suitable calculation. In other words, if you use a sign which does not have its own dedicated light source, you need to put a bulkhead within 2 meters, a bulkhead or an emergency fitting within 2 meters of it, and you need to prove via calculation that you're getting 100 lux on the front of the sign under general conditions and 5 lux under emergency conditions. Now, I recommend generally, because of that sort of arduous nature, that you just purchase essentially internally illuminated signs. Just a word of warning around photoluminescent signs, because we did see this a couple of years back, so sort of glow in the dark signs. The requirement on them is exactly the same. You still need to provide 100 lux in general conditions and 5 lux in emergency supply failure. You still need to put a bulkhead next to it within 2 meters to provide that level, and you still need to prove that via calculation. Now, one of the benefits, other than not having to run all of those calculations, is if you do have an internally illuminated sign, the viewing distance is actually 200 times the height of the sign. Whereas if you use an externally illuminated sign, you times the height of the sign by 100 to give the viewing distance. Now, most sign manufacturers will just provide the viewing distance in terms of meters to you rather than providing that sort of calculation. So the general thought process here is, because if you have an internally illuminated sign, you can double the viewing distance for the same size sign, and you can use half of them essentially. So it's just a word of note. Now, signs should be mounted above 2 meters, but no more than 20 degrees above line of sight from the maximum viewing distance. So it's a little trigonometry calculation, and essentially what that means is, I think from memory, the last time I did it, I think a 30-meter sign could be at about 7.5 meters high, but sort of in warehouses and large heights where you can't mount the signs at, let's say, 2 meters or 2.5 or 3 meters, you need to put a larger and larger sign up if you're mounting it up higher. But it's a quick trigonometry calculation. I actually have this on here. So a 20-meter sign can be at 7.2 meters height, and a 30-meter sign can be at 10.9 meters height. So if you had to go higher than that for whatever reason, you'd need a special sign, a larger viewing distance to be able to mount higher and higher, for example. So a little note on twin spot projector units. I must admit they're not as popular as they used to be. They produce a beam of light and not a flood. They're generally suitable for escape route coverage and not open area coverage. To actually, I have done schemes on these to actually, light an open area with twin spots as the sort of known, or beam lights. You have to be very specific in the angles to actually produce a meaningful result, and then they get installed, but they're not on any sort of locking mechanism. So it's very difficult to actually achieve that illumination level and requirement and compliance. What I will say is they are quite useful nowadays for covering high risk areas. So quite useful to point the illumination source directly on a high risk location, such as, for example, I don't know, a laboratory area or an acid bath or something like that. Now, I touched upon diversity requirements of 40:1, which is a maximum to minimum ratio. And I think at the time I said 20 lux under the fitting and 0.5 lux as a sort of a minimum maximum would just be hitting that ratio. Now, it is a common issue with central power supply conversions. So that's where you're converting the mains luminaire on a central power supply or a central battery unit, as they're often known, and generally in combination with low mounting heights. So where you often see issues is on in car parks, for example, where an anti-corrosive is converted, and you'll generally see issues with diversity. LED bulkheads, which are designed for emergency lighting, they'll generally only hit 2 to 5 lux under the fitting, so they'll be well within that requirement if it's specifically designed for emergency. Like I say, keep an eye out generally when it's central power supplies and its mains luminaires that you convert in. That tends to be where it becomes a problem, and you have to add more and more luminaires to bring your minimum up to a more reasonable level to meet your ratio. Okay, we'll quickly touch upon product authentication. So the government RRO, Regulatory Reform Order, which I mentioned at the start of this CPD, strongly recommends the use of kite-marked products, which is a proof of a component quality, proof of all performance claims such as light output, independent test of distribution and IP rating, and proof of safety and reliability and consistent quality. Now, if you have a kite-marked product and you have an ISO 9000 certified facility as a manufacturer, you can have your spacing data checked, and essentially you can use spacing data to provide your emergency scheme. Otherwise, you need to do photometric measurements and use a sort of a calculation platform. So just check that the spacing data is authenticated, and then you can use that spacing data. So that's an example there. And again, like I say, I do recommend the use of spacing data. I think they're very useful for providing a very quick and compliant design in most cases. One thing to be considerate of is derating factors. It's not as problematic now as it used to be. So I'll run through these, but dirt anywhere from 5 to 20% depending on the environment. In particular, the clean environments, I'd suggest that's more towards the 5%, and 20% towards the dirtier environments. Aging of the lamp. Now it depends on the light source. So LEDs have a higher life, and they don't reduce their output as much under age. It also depends if you're permanently running that lamp or if you have a non-maintained system. So I mentioned earlier about exit signs being permanently illuminated. Typically now, emergency lighting, you have it as non-maintained, so you don't illuminate the lamp under normal conditions, you only illuminate it under emergency. So there is no as such derating of the lamp in terms of the output because you aren't running the lamp. So it can be close to 1% or 0% if you are only running that lamp under test and under an emergency condition. One to be wary of, end of discharge of the battery. Now, most manufacturers will quote end of discharge of the battery, or what's known as emergency ballast lumen factor, or EBLF. If you see ballast lumen factor, or BLF, that is at the start of the discharge of the battery. So you've got to be really wary of that. But if you see ballast lumen factor, be wary of it. EBLF is emergency, and it is at the end of the discharge of the battery. So 0 reflectances from all surfaces must be assumed in your calculations, and most calculation suites will do that for you. Now, spacing data is usually performed at a 20% reduction. So, and generally that allows for the dirt and the aging of the lamp, and there is 0 reflectance and the end of the discharge of the battery. So usually it's allowed, but if you have a particularly dirty environment or you are running your fitting maintained, you may need to consider running calculations rather than relying on spacing data. And just a note around this, so extract of 5266 completion certificate. So at the end of 5266, there's a completion certificate which should be signed and completed for every application within the UK. You sign declarations of design, installation and verification, and it covers most of the points that we've talked about today, open areas to 0.5 lux, escape routes to 1 lux, emergency luminaires located at points of emphasis such as changing of directions and changes of level, for example. So it covers most of those parts, and with that signed declaration should be provided photometric data. Now that's either spacing data, as I mentioned, ICEL 1001 registered tables, calculations as detailed in LG12, which is hand calculations. Often I've never really seen those provided, or indeed computer printouts, so such as Relux, Dilux, or other computer suite calculations. And that all goes with the test logbook as part of that completion certificate of the design. So I think the last two sections we'll touch upon testing of emergency lighting, and there's a very short section around wiring requirements. So if there's any questions, we'll touch upon those at the end. So need for testing. So testing is mandatory for the end client. Monthly, there should be a brief functional check, checking afterwards that the fitting recharges correctly. Annually, there should be a full discharge test for the full rated duration of the battery. Again, checking afterwards that the fitting recharges correctly, and arrangements should be made to cover the recharge period, which is typically 12 to 24 hours. Generally, perform that test when the building is empty and test alternate luminaires, for example. So generally, there's different testing options. The first one is manual test, standalone self-test, self-test with some form of central reporting, and again, we sort of central reporting and notification, very similar those last two, but we'll run through them. So this is a typical example of an emergency luminaire with a charge indicator on the sort of the top left of those three images, an emergency gear pod, maybe with a self-contained battery pack, and then on the bottom right is an example of the wiring. Essentially, a permanent live is taken before any switches, so that the batteries can remain charged. And if there's ever a failure of the general lighting circuit, which takes out the downlights as shown there, a relay within the emergency product switches and powers the lamp directly from the battery, essentially, and turns the battery on. Now, to test, sorry about this, to test that product requires reliance on the user to remember to test, to inspect at the start to ensure that the charge indicator is working, inspect at the end of the test to ensure that the lamp has illuminated for the full duration, check for correct recharge so that the charge indicator re-illuminates, and relies on the user to record the results and ensure continuity between multiple different tests. Now, typically that's achieved via the use of a key switch and manual interaction with the product. Now, self-test employs a little bit of intelligence within the Luminaire, so that Luminaire can actually test itself by breaking its own power supply, essentially. And typically the charge indicator would employ either a bicolor LED, so it might flash red or amber, or indeed it might flash or buzz to indicate that there's a failure if identified. And typically those failures are identified by different flashes. So if a battery fails, it might flash red. If the LED has failed, it might flash green, for example. Now that takes some reliance away from the user to remember to test and then inspect at the start of the test, and generally ensure continuity, because you can usually set the test apart on adjacent fittings, for example, 24 hours or 12 hours apart. And it takes the reliance away from the user to check for correct recharge. However, the user still needs to inspect the products once a month and record the results. And then the step up from that is a central addressable system, and essentially you run a data pair around all of your products which have that self-testing functionality generally, and the reliance to actually inspect the product is done via the controller, and then with some form of visualization, the user no longer needs to record the results. It emails or it is visible on a BMS system, whatever it may be. But essentially that logbook is held within software and visualized for the end user. So those are the sort of the test systems as you step up through the different requirements. Now, the last section is only a short section, so we are probably going to be a little bit ahead of time here. So I would say we'll leave some time for some questions. But wiring requirements. Supplied to self-contained fittings must be from the same circuit as local mains fittings. They should be wired in the same type of cable, and that allows the emergencies to activate if the general lighting circuit fails. So for example, the blue line here shows the emergency circuit to the emergency product coming from the same source as the general lighting. So again, as I say, and then if we have a power failure on that general lighting circuit, for example, the emergency will activate. Whereas if you, and this is shown how incorrectly to do it, if you take the emergency circuit from an adjacent circuit, you could potentially have a power failure where the emergency lighting will not activate in that area. Now, maintained wiring, where all of the products are maintained and permanently illuminated, can be wired from their own separate source because they are permanently illuminated. But again, there is some, not really deemed appropriate nowadays, apart from exit signs because of the power loss. So maintained fittings are permanently on, so they can be wired on a separate circuit. So just a little bit of further reading. So there is some information on gov.uk. There is some requirements under Part B, which are quite useful to read through, but they generally point towards 5266. We have an Eaton website, LifeSafe UK, and also Safe Evacuation UK. And there is some information at the Lighting Industry Association page, ISEL. So I'll pass it over for any questions. But other than that, I think that's it. Jamie, do we have any questions at all?
Hi, Harry. Yeah, we have a couple. If anyone else has any questions, obviously feel free to enter them now, and we'll get round to as many as we can. So first question, Harry, from Ben, is asked, do you have a quick reference guide, book or PDF for all the spacing and lux levels for ease of reference when designing future jobs?
Yeah, that is a good question, actually. So we have spacing data. It's done generally per product. I might have something actually which highlights different products and their typical use cases. So that's things like, for example, what I know as a pin spot, which is just a small LED downlighter. And I think I've got on there, useful for front of house spaces such as offices. And then there's a little spacing data calculation there. And then I've done the same for a product like Zeta, which is a bulkhead, that Rexel stock, which is used for sort of back of house plant areas, for example, and a little spacing data. So yes, I could probably get that out to yourself, Jamie, and then could that be provided or maybe on your website?
Yeah, I can send that on to everyone who attends. And just a reminder, if you do have questions, anyone, please put them in the Q&A box section so we can see them. Okay, second question is from Sam. Sam asks, if an exit sign is installed above a doorway onto a staircase landing, up/down, down being to safety, would an exit sign with an arrow be permissible above the doorway onto that staircase, or would it be an arrow up exit sign above the door onto the staircase?
It should be arrow up. If the doorway leads into the staircase, over door it should always be up, which is a continue on from here. I believe the regs say arrow down is for change of level. So essentially outside of the staircase through the door, it should be arrow up through the door. And then if required, an exit sign in the staircase, which is either arrow down above the stairway, or indeed a diagonal exit if you can mount it on the wall, sort of leading parallel to the stairway, if that makes sense. Yeah. But yeah, it should be arrow up at all cases above doors.
Another message from Daniel: are exit signs on final exit doors to external areas supposed to be a down arrow?
No, I believe there's still arrow up. Yes. I will double check the wording of the regs, but I believe all exits on all final exit doors should be arrow down. Sorry.
Arrow up. Yeah.
Arrow up over all exit doors. Apologies.
Yeah. Question from Eric: is there any guidance on the types of military sites that are exempt that you mentioned?
That is a good question. I would have to get back to you on that. if that is okay. That is within the regulatory reform order. No, I don't know is the answer. I would suggest that the military site would be able to provide you the information as to if they sit within under their own regulatory reform order, or indeed they sit within under their own regulations. But I'll double check that. It's a good question.
Yeah, if we can find any information on that, Eric, we'll come back to you with that. From Bruce, if we have an open area under 60 meters squared, can we add one light into this area?
If you have an area under 60 meters squared, can you add an emergency luminaire in that area? Is that the question?
Yeah,
so
if you
I
have
often,
an open area.
Yeah, so I often see, I often see areas under 60 meters squared having an emergency luminaire I think as a sort of generosity, because I think, in certain circumstances, I would personally feel a little bit safer in an area, let's say 50 meters squared. It's still a fairly significant area. That could be a classroom with, I don't know, 10, 15 people in, or something like that. I like to think of it as an allowance to allow people to escape. But in terms of the requirements, there's no requirement, but I tend to allow it. I tend to like to put an emergency in.
Yeah, fair enough. Question from David: if there is an existing arrow exit sign on inspection to an existing building, would this fail the inspection or just be a recommendation?
It'd be a recommendation. Yeah, it's allowed in existing buildings. They don't retroactively apply the regs generally, so it's very rare anyway. So no, it would be a recommendation. Like I say, in terms of the exit signs, if they are already there, I would follow the same strategy. So if there are Euro signs and they're arrow down above doors, generally the recommendation is that you follow the existing format and style, so you'd continue that. And that is in order to not confuse occupants. So for example, you have Euro, an arrow down above doors, and then you suddenly build a new part of that building or an extension, and you start throwing ISO, arrow ups. The sort of thought processes, it could cause confusion. So you either do one of two things: you match the existing installation, or indeed you rip out the existing signs in the original installation, and you fit new ISO signs to everything, which I can appreciate may not be appropriate, but yeah.
Yeah, so consistency is obviously valued most. Another question from Jay: what is the lux requirement on the tread of each stair within a stairwell?
1 lux as an escape route. 1 lux on the tread of each stair as an escape route generally.
Yeah. Question from Steve: who can repair emergency lights, lamps / battery changes? Is there a qualification or requirement?
Yeah, so it's not as clear as I think there is some work being done to try and narrow this down, but because the regs are very loose in the requirement and say a sort of a competent engineer, but there's not as much wording as we would like. I believe there is some work being done by the FIA and the LIA to sort of narrow that down a little bit more as to the competency of engineers around emergency lighting, and that's across the board. So that is for application engineers as well as installers, for example. But yeah, at the moment, I think it's just quote unquote competent engineers.
Yeah. So yeah, the answer is no specific one at the moment, Steve, but obviously they're looking to maybe update that as we move forward. Okay, bit of a lengthy one here from Sam. A room which houses multiple lighting circuits in excess of 40 NO primary lighting circuits, would it be permissible to install a phase monitor relay and wire a separate emergency lighting distribution setup and wire sub-circuits from that? As the room doesn't lend to install additional containment, the phase monitor isolating the supply to the emergency luminaires upon a loss of the respectable phase the emergency lights are connected to, or to other phases which are not directly connected to the emergency luminaire circuits. I hope that makes sense.
I believe it does, and apologies if I'm wrong here, but I think I get the ethos. So I showed on the last page the wiring. I might even go back to it, which showed the emergency luminaires fed from the same space as the general. Let me just show you. I think it was here where the emergency, as you can see here. So the general lighting is here, general lighting circuit, and the emergency essentially taps off before any switches to power the emergency. I think what did you say it was Sam was getting at there is if he has a very large area with multiple general lighting circuits, could he potentially use what's known as a phase monitor device? So it monitors multiple general lighting circuits and essentially activates the emergency if any one of those circuits failed. Now we do that in central battery applications, I mean, very, very regularly. I don't know whether it would be permissible. My instant sort of thought is yes, but the problem is you are discharging the batteries for the whole installation. In that scenario, if one general lighting circuit fails, it's a really good question. I think what I would prefer to see is a level of redundancy where rather than forcing the permanent supply to the emergency to fail, you actually brought on a switch supply to switch the emergencies on as a single, as a first instance, rather than breaking power. But in that scenario, I would suggest it would be permissible. It might be best to sort of reach out to me individually there, if that's okay, Jamie, and we can grab a discussion on that. But it's a very good question, but I can't see any problem with it as long as you were switching the fitting on rather than forcing the power to fail.
Well, yeah, Sam, I'll put you in touch with Harry directly, and maybe if you need any further information on that, we can sort that out. A couple more questions to go then.
Yep.
Got one from Mark. Interesting one. I was told Eaton are discontinuing production of emergency lighting products. Is this incorrect or correct?
Yeah, that's certainly incorrect. Unfortunately, and it was unfortunate a couple of years ago, we did have to close down the general lighting plant. So we don't offer general lighting anymore. So that maybe something to do with it, maybe some cross wires there. No, emergency lighting still going strong. We've got plants in multiple locations. There's one in Doncaster where I'm generally based, which manufactures static inverters, AC static inverters. We've got a plant over in Germany, an AC/DC plant, and some self-contained dotted about as well. So no is the answer in short. But yeah, unfortunately, the mains lighting plant did close. Yeah, and just to add to that, Mark, kind of at Rexel, we've undertaken a lot of work recently with Eaton to kind of improve the visibility and the range and the information that we have on emergency lighting products as well. And you can check that out. It's linked on the main homepage of the Rexel website, and you get a lot more information on the range of different Eaton emergency lighting products that are available, with some features and benefits as well. Last one then, from Lewis. What would the lux level need to be in a lift area, i.e. lifts, escalators, for it to be adequate to the current regulations? Yeah, the lift areas, I believe, are 1 lux. Assuming that it's a lift lobby, it'd probably be 1 lux, isn't it, a part of the escape route. Escalators are quite a strange one. I'd have to have another look at the regs, because I believe there's it's frowned upon to use them as escape. You should provide 1 lux on the escalator to get occupants off of the escalator, but you shouldn't use them generally as part of the escape route. So I would suggest it would be 1 lux in both scenarios there, in front of the lift and also over the escalators in emergency conditions. I'm talking here.
Yeah, brilliant. Yeah. And that's all the questions done. Obviously, if anyone does have any further questions, you can send them to me at marketing@rexel.co.uk if you think of something after, and I'll try and liaise with Harry to get those answered. Thank you for everyone for joining, and mostly of all, thank you to Harry for his time and his knowledge. As we mentioned at the start, this webinar is CPD accredited, and certificates will be sent to you guys directly from CPD. just bear in mind this can take 4 to 5 weeks for the process to go through and for emails to land in your inbox. For more information, obviously you can visit rexel.co.uk or the Eaton website. As I mentioned to one of the questions there, we have a lot more information now live on the website for Eaton products and solutions as well. Some really innovative, good products are available at the moment. So thanks again, everyone, for joining. Harry, you got anything to add?
No, I think thanks for all the questions and everyone's time. You know, I appreciate everyone's busy at the moment, so no, I appreciate everyone's time and the questions. So yeah, I'll get back onto the few areas that we weren't able to answer, the military sites and the just double check the arrow up over final exit doors and get that answered out. But no, thank you for everyone's time.
Yeah, thanks everyone, and enjoy your bank holiday next week. Take care.
Take care.
Bye all.